No, it's not reaching you people actually. So page number 77, we have a checkpoint. Suggest why the electronegativity of fluorine is greater than that of chlorine, despite the fact that the nucleus of chlorine atom contains more protons. Why the electronegativity of fluorine is greater than that of chlorine? Electronegativity, first of all, now I'm answering this question. First of all, electronegativity is the force of attraction which is felt by the electrons which are shared between two atoms, and that force of attraction is from the nucleus side. So the stronger the nucleus, the stronger will be that force of attraction. The smaller the atom, the stronger will be that force of attraction. The smaller the atom, the effective will be the nucleus. The more the nucleus is effective, the stronger force will be applied, and that stronger force, I mean to say, highly electronegative. So now comparing fluorine and chlorine, chlorine is larger in size, the nucleus is not that much effective as compared to fluorine. That's why fluorine has a greater attraction towards the shared pair of electrons as compared to chlorine. So that's why there's a high electronegativity value for fluorine as compared to chlorine. Are we clear with that?
Yes, sir.
Let me repeat it once again. Fluorine is smaller in size. The nucleus is much more effective. So it has a greater authority over the shared pair of electron. That's why the electronegativity is larger as compared to chlorine, which is larger in size. The nucleus is not that much effective as compared to fluorine. That's why it has a smaller electronegativity value. Now I'm moving to question number 2 of the checkpoint. Ionic bonding and covalent bonding are two extremes of chemical bonding. Many compounds have bonding that is intermediate in character. Give an example in each case. Explain what is meant by the term ionic bond. So first of all, what is an ionic bond? We need to be having 3 points in our mind. I'm explaining ionic bond. First of all, it's a bond which is made between metals and non-metals. Metals and non-metals. Okay? Number 2, second point is by the complete transfer of electrons. Transfer of electrons. And third one, with a strong electrostatic force of attraction. With strong electrostatic force of attraction, ESF. So these 3 points are very important when you're defining the ionic bond. Moving on to the covalent bond. What is a covalent bond? So the first point about the covalent bond will be, it's a bond which is made between metals. Atoms or group of atoms? It's a bond which is made between non-metals, non-metals. By mutual sharing of electron. This is the second point. Mutual sharing. Mutual sharing means 50-50 sharing. And which force of attraction is holding the two atoms together? The force of attraction between the two nuclei. The two nuclei and the shared pair of electrons. And the shared pair of electrons. Okay? So these 3 points are very important while you are explaining the covalent bond and defining the covalent bond or explaining the covalent bond. Here in this case, both things are same. Okay, explanation will be just a little bit of example will be given, and you're going to work on that example along with that. Okay. Now I'm moving to part 2 of the same question. The same question is having part 2 here, and that part 2 is asking select a compound that has bonding of an intermediate character and explain why it has this type of bonding. Now, bonding of an intermediate character. Like I've given you the example of sodium chloride, now I'm giving you the example of cesium chloride. Let us see cesium chloride, the cesium fluoride actually. The value of cesium is 0.7 electronegativity value, and the value of fluoride is 4. So CS Cl, we will see this and we'll prove it on the difference of electronegativity value. Or you can take CsF, cesium fluoride. Fluorine is 3.5. So 3.5 minus 0.7, and for cesium fluoride 3.4 minus 0.7. So the result which you are getting from 3.5 is 2.8, I guess, and 4.4 minus 0.7 is 3.3. So now both of these results we will see in the table which is provided to us. First of all, 2.8 we will see. Okay, shall we check 2.8 first? So 2.8 is 86% ionic, and it's mentioned here. It's 86% ionic, 2.8, and 3.2 is 92% ionic. So these two are, like, which one is having more intermediate character? With 82%. Are you with me?
Yes, sir.
So this is 82%, and this one is 92%. Sorry, 86% and 92%. So this is more intermediate, okay, as compared to fluoride one. Fluoride is more ionic in nature. Are we clear?
Yes, sir.
Okay, good. Moving on to the third question now. This third question is telling us, place the following bonds in order of decreasing polarity. Now polarity, decreasing polarity, explain how you arrived at this point. Now to explain this we need to move a little bit towards the polarity once again. Look into this polarity area. And see what are we getting here. Consider a polar covalent bond as a covalent bond that has some degree of ionic character. If the electronegativity difference is large enough, then the main type of bonding is ionic. A very approximate measure of degree of ionic character is given in this table. So now we are going to see the polarity and we are going to see the difference. If we are getting the difference closer to 4 or more than 1.7, we are having more ionic character in it. Right? And the more the ionic character are there in it, the more is the polarity there in it. Are we clear with this point? The more ionic character, the more is the polarity. So I'm just moving on to the table once again, moving to the question once again. CBR. So CBR, move on to the table, find out the value for C and BR. Now moving on to the table, we find that C has a value of, here is the table, Let me clear these things out of it. Yes, please. I'm still sharing my screen with you. I don't know whether you're getting it or not.
Yes, sir, we are getting it. It's very laggy.
Yeah, there is a problem in the internet actually. Now, C and BR, the table, I'm going to pick C and BR. C is 2.5, BR is 2.8. So 2.5 and 2.8, the difference is 0.3. Okay? So let's move on to that area and put the value for this bond. So CBr, I'm getting 0.3. CCl, we will see that one. Now Cl is 3.5 electronegativity value. Check it in the periodic table. Cl is 3. It's 3. Sorry, 3.2, not 3.5. It's 3. So carbon is the same, 2.5. We'll see it now. 3 minus 2.5. What are we getting? 0.5.
0.5.
So we got for the second one 0.5. We are moving towards ionic character. Okay. So the more we are moving there, the more we are getting polarity. For CF, it's much more. It's 4 minus 2.5, almost 1.5. And for CI,
So 0.
CI is 0. They both have the same electronegativity values.
Yes, sir.
Let us see in the table. Okay, 2.5 and 2.5, we are on the 0. So 0 means it's a pure covalent character. So CF is more towards ionic, right? And the question is, place the following bond in order of decreasing polarity. The most polar first. So which one is the most polar one?
CF.
And then?
So CCl.
And then?
CBr.
And then? The last one, CI.
CI.
So we have CF, followed by CCl, followed by CBr, and followed by CI. So this is the maximum character, and this is the minimum character. Are we clear with this point?
Yes, sir.
You have anything to ask? Here you can ask now. If you want to ask anything, you can ask now. Okay. Now we'll see bonding in discrete molecules. Simple molecules. We'll first of all see the dot and the cross diagrams, and then we'll work on their structures. So first of all, how many discrete molecules are there to be understood in your course? So we have water, we have ammonia, we have methane, we have carbon dioxide as well. These are certain molecules. I'm not going to the next topic because the next topic is starting now. So let me first of all tell you about these three molecules. Discrete means simple, okay? So when we are getting discrete molecules, this word is it's an examiner word actually. when the two atoms or the three atoms or the four atoms which are constituting the molecule, when they are balancing the charge electrically, when these groups are balancing each other, they are making the molecule neutral. Okay, water is neutral because oxide is -2 and the two hydrogens are +1 and +1. So they're balancing each other effect. Nitrogen is 3 minus and the three hydrogens are providing with 3 plus charge. Carbon is plus and -4 both, but in CH4 case it's -4 and the four hydrogens, each one is carrying +1 charge, they are balancing its effect. So it's neutral molecule actually. Are you getting my point? So the important thing is to understand
Yes, sir.
the dotted crosses. Once we get the dotted crosses, then later on we'll start